So those who are online are able to see and hear me?
Yes, sir.
No. So we did problems. You're able to see the screen also, no?
Yes, sir.
Okay. So we did problems based on one-dimensional motion, right? So we'll start with this problem today. Listen to this. On a foggy day, two drivers spot each other when they are just 80 meters apart. So there are two drivers who spot each other when they are 80 meters apart. They're traveling at 72 kilometer per hour, 72 kilometer per hour and 60 kilometer per hour respectively. Both of them applied brakes, retarding their cars at the rate of 5 meters per second square. So here and here the acceleration is minus 5 meter per second square, right? Determine whether they avert collision or not, right? So how to proceed? So find the distance traveled by each after the brake has been applied, right? So once the brake has been applied, what is the objective of applying a brake? To bring the object to rest, okay? So when you apply the formula, v square minus u square is equal to 2as for both the objects, right? You will get two distances. If you add those two distances and it comes out to be 80 or greater than 80, they will collide. If not, they will escape, right? So can you try that part and tell me? So what are we supposed to do? For car 1, right? When I apply this formula, v is 0. So 0 square minus, what is the initial velocity? 72 kilometer per hour. So 72 kilometer per hour, if you convert it to meter per second, it will be 72 into 5 by 18, which will be 20 meter per second, right? So 0 square minus 20 square is equal to 2 into acceleration is minus 5 into the distance, I'll call it as S1. Okay. So when you calculate this, you will get 400 is equal to 10 times S1. Minus and minus will get cancelled, which implies S1 is equal to 40 meter. Similarly, if you take for car 2, then apply the same formula. 0 square minus u is how much? 60 kilometer per hour. No, it is 60 into 5 divided by 18. It is 300 divided by 18. So 300 divided by 18 is going to be 150 divided by 9. 50 by 3. Right. So it is going to be 0 square minus 50 by 3 the whole square. Right. 50 by 3 the whole square is equal to 2 into minus 5 into S2. So 50 by 3 the whole square is going to be 2500 divided by 9. So 2500 divided by 9 is equal to 10 times S2. 10 will cancel the 0, which implies S2 is equal to 250 divided by 9. So 250 divided by 9 is how much? So if you add 40 to this 27.75, it is less than 80. So they can avoid the accident. Right? There is going to be no collision. Okay. Right? Shall I proceed? So there are 300-meter sprinters. So 300-meter sprinter increases her speed from rest. Oh, I think there is a mistake. There is no, it's not 7. It is A. Sprinter. No, I'm just looking. There were 3. Yeah, there were 3. They would have called sprinters. No. Okay. Okay. Coming from the beginning, a 100-meter sprinter increases her speed from rest uniformly at the rate of 1 meter per second square. So initial velocity is 0 and she is accelerating at a rate of 1 meter per second square up to 3/4 of the total run, right? And covers the last quarter with uniform speed. So basically, if you take the whole journey as D, if you take the total distance to be D, 3/4 of the distance is covered with an acceleration of 1 meter per second square. And here the velocity is uniform, right? The question is, how much time does she take to cover the first half and the second half of the run? Okay. So here, if you see, there are many unknowns. If I take u here, u is equal to 0, right? So when I think of time, I can use two formulae. What is it? V is equal to u plus at or s is equal to ut plus half at square. In either of them, what I need is, in the first one, if I have to apply, I need to know the final velocity. In the second one, I need to know the distance covered, right? So what we'll do is, oh, sorry, 100 meter is given. No, that I forgot. Yeah, D is equal to 100. You missed that point. So it is going to be 75 meter and it is going to be 25. Yeah, then the problem is simple. Right. Then we'll get, if you apply S is equal to UT plus half AT square. For the first part of the journey, it is going to be 75 is equal to U is 0. Half into A is how much? 1 into time square. That's what we need to find. So T square. So which I'll call it as T1 square, which implies T1 square is equal to 150. So what is the value of T1? So root 150 means what will you get? Do prime factorization and see. You get 25 into 6, no? So it is going to be 5 root 6. So 5 root 6 seconds is what she takes to complete the first half. I mean, 3/4 of the. But wait a minute. See here, the question is not about how much time she takes to cover. Is this taken as the first half? Yes. It is not necessary that there is a first half. Right. So actually, this is wrong. Okay, if it, yeah, we can know. See, but this is the time taken for 3/4 of the journey. See, if at all the question was there about 3/4 of the journey, this is how we find. It's an extra information, we can have it. Okay. But the question is intended to find what is the time taken for the first half and the second half of the run. Right. So when I take, so wait, let me read the question at 3/4. See, 50 meters you'll be able to cover in 10 seconds. Because when you put 50 here, you will get 100, T square is equal to 100. But I'm just trying to understand when they say first half, are they trying to say it is 3D by 4 or it is going to be 50 meter? How much time does she take to cover the first half and the second half of the run? So did they mention this at up to 3/4 of the total run and covers, they use a word last quarter, that's it. So it is not matching. Okay. So first half means it is going to be 50 meter. So the first half, if you apply the formula S is equal to UT plus half AT square, when you put S is equal to 50, so 50 will be equal to 0 into T plus half into 1 into T square, which implies T is equal to 10 seconds. So this is the time taken for the first half of the journey, right? Whereas if you look at the second half, there is a small issue. What is it? So when you see from 50 to 75, if you consider this to be the number line, between 50 to 75, she is accelerating, whereas here acceleration is 0. So for the second half of the journey itself, will break the time as T2 and T2 dash, or T3 also we can take it, just a notation. Okay. But for us to calculate how much time it takes to cover this distance, what are we supposed to do? If you apply S is equal to UT plus half AT square between the journey 50 meter to 75 meter. Okay. This is where you need to answer one question. What is the velocity here? So to find the velocity at the point where she's crossing 50 meter, you will apply the formula V is equal to U plus AT. So here, whatever is the value of V with respect to the first half of the journey will become the initial velocity for the half of the second part of the journey. Because the second journey is broken into two parts. I hope you're able to understand that. This is the trickiest part here. So the final velocity of the first part of the journey will become the initial part of the, it's not complete second part, half of the second part of the journey, right? So V is equal to U plus AT, V is equal to U is 0 plus acceleration is 1 into how much time did she take to reach there? 10 seconds. That we have already calculated. So it is going to be 10 meter per second. So the velocity here is 10 meter per second. and this acts as the initial velocity here. So I'm doing it for 50 to 75 meter. No, so how much should I write? How much is the distance covered between 15 to 75? 25 is equal to u is how much? 10 into you have t plus half into t square, because acceleration is 1. So if I take 2 to the other side, then I'll get t square plus 20t minus 50 is equal to 0. Sorry, plus. No, I'll take LCM. No. T square plus 20t minus 50 is equal to 0. So what is the value of t? 50. How can you split it? If it is not working, then the only option is you have to take this. T is equal to minus b plus or minus root of b square minus 4ac. So 400 plus 200. 4 into a is 1, c is minus 50. So it will become plus the whole divided by 2. So it will be minus 20 plus or minus, it is root 600. So I can write as 10 root 6. The whole divided by 2. Right. So you can either write it as minus 20 minus 10 root 6 by 2 or minus 20 plus 10 root 6 by 2. So which one will be more apt? This cannot be taken because time cannot be negative. So this one is taken into consideration. Okay, this is the time taken to cover the distance between 50 to 75 meters. So how much time is taken to cover the distance from 75 to 100? Again, apply S is equal to ut plus half at square. So S is how much? From 75 to 100? 25. What is the initial velocity here? It's not 0. What is the initial velocity when she has covered 75 meters? Again, apply this formula. But the problem is, I don't think anyway this complicated, but yeah, we'll see. See, when she has come here, right, what will be the velocity? For that, you need to apply v is equal to u plus kt again. Right. So when you apply v is equal to u plus at, you can either take this total distance where you can consider this to be u and this to be v, or if you take only between 50 to 75 meter, you take it only between 50 to 75 meter, this will become 10 meter per second will become the initial velocity, and final velocity is v, acceleration is 1, and time is this. Okay. So 10 root 6 is how much? 2 point. Root 6 is how much? 2.3 here. Just calculate. Okay, 2.4, no. So 2.44 means, can I take it as 24.4? So 2.44 into 10 is 24.4 minus 20. 4.4 divided by 2. It will be 2.2 seconds. Right. Take this 2.2 and substitute it here. So when I take the journey between 50 to 75, v is how much? That's what we need to find. U is 10 plus acceleration is 1 into 2.2. It will be 12.2 meter per second. Right. So this 12.2 will be the initial velocity for 75 to 100. So here I'll substitute this 12.2 into time is what we need to find. So time will be equal to 25 divided by 12.2, which is greater than 2, because 25 divided by 12.5 will be exactly 2. So since the denominator is less than 12.5, it will be 2 point something. Okay. So those many seconds. So how much is it taking for the first half of the journey? It is 10. And how much time is it taking for the second half of the journey? 2.2 plus this 2 point something. It is taking 4.4 seconds. 4 point something seconds. Okay. So let me check the answer once. It's 4.24 seconds. Okay. I hope you could understand. Those who are online, could you understand?
Yes, sir.
Sorry?
Yes, sir. It's clear.
Okay. Done. So look at this one. So there is a motor car which starts from rest. So u is equal to 0 and accelerates uniformly for 10 seconds. So there is a uniform acceleration for 10 seconds to a velocity of, so then it reaches a velocity of 20 meter per second. Okay. After that, it runs at a constant speed, right? So this is the first part of the journey. So if you look at the second part, it is running at a constant speed. And the third part is, it is brought to rest, right? So it is brought to rest in how much time? In 40 meter, and it is traveling with a constant acceleration, right? So the total distance covered is going to be equal to 640 meter. Listen. Find the value of acceleration, retardation, and the total time taken. Okay. You need to find the acceleration, retardation, and the total time that it has taken. Right. So what we can do is, if I take here the distance to be S1, so I can apply the formula S1 is equal to U1 T1 plus half into A1 T1 square. Can I do that? So when I apply that formula, I'll get the answer here as S1 is equal to, how much is U1? 0 plus half into acceleration is how much? That we don't know. We don't know, right? Into 100. So S1 is equal to 50 times A. Right? S1 is equal to 50 times A. But since they have given the velocity that is attained after 10 seconds, we can use that formula also. What we use? V1 will be equal to U1 plus A1 T1. V is equal to U plus AT. So V1 is equal to, what is the value of U1? It is 0 plus what is the acceleration that we don't know, into how much is the time it has taken? 10. So V1 is 20, no? So V1 is 20, then acceleration will be 2 meter per second square. Take this and substitute it here. So you will get the displacement as, so the distance covered by the object in the first part of the journey is 100. Right? So any doubt? Any doubt? T1 square, time is 10 seconds. So 100 square is, 10 square is 100. Got it? Is this point clear? So the second part, what is happening? The object is traveling with a constant speed. So acceleration, we found it is 2 meter per second square. Right? So since the first part of the journey is covering a distance of 100 meter, right? And if you look at the last part of the journey, they are saying that it is brought to rest in 40 meter. So what is the total journey of the first and the third part? 140 meter. But what is the total distance covered by the object? It is 640. Out of 640, how much should you remove? Out of 640, if you remove 140, you get 500. But what does this 500 represent? This 500 meter is covered with constant speed of how much value? That they have not given? It is indirectly given. See, it is 20 meter per second. Why is it so? Because yes, the final velocity of the first journey will become the initial velocity of the second journey. So This 20 meter per second is going to be the initial velocity for this distance of 500 meter. But what are they expecting? What is expected in the question? You need to find the acceleration, retardation, and the total time taken. Let it come. But here, let's try to, retardation is third part, but we need the total time, no? So here what we can do is, you will apply V is equal to U plus 80. Here actually there is no point in applying this. A is 0. So we'll go with V square minus U square is equal to, okay, V square minus U square is equal to A is also of no use. Then what will you do? Since you need the time, you can apply S is equal to ut plus half at square. So for the second part of the journey, we will apply S is equal to ut plus half at square. I'll write S2, U2, T2, A2, T2. So what is the acceleration the second part of the journey? This is completely gone. What is the displacement of the particle? 500. What is the value of U2? It is 20 into T2. So what is the value of T2? So it takes 25 seconds for the object to cover this 500 meter. Are you clear with this? Clear? So this is for the second part. Am I clear or not? Right. So what about the third part? Yes, for third part, V3 will be 0, but U3 will be 20 meter per second. Why is it so? Because they maintained a constant velocity till that particular time. So U3 is equal to 20 meter per second. Then how much is S3? 40 meter. Then what about, so you have all these values. So A3 is equal to how much? So we don't even know the time. So wherever this V becomes 0, right, always apply V square minus U square is equal to 2S. Whenever you have a problem where there are questions that are based on deceleration and the object is brought to rest, apply this formula. So V3 square minus U3 square is equal to 2 times A3 into S3. So what is V3 square? 0 is implies, what is U3 square? Minus 400 is equal to 2 into acceleration, I don't know. What is the displacement? It is 40. So this will cancel this 10 times and this will cancel. So A3 is equal to minus 5 meter per second. Right? Since you know the acceleration here, will we be able to calculate the time also? Right? So to calculate the time, I'll apply S3 is equal to U3 into T plus half into A3 into T square. Either you can use this or you can directly use V is equal to U plus 80. That is simpler. So you can apply V3 is equal to U3 plus A3 into T3. What is V3? What is U3? 20. What is A3? Minus 5. What is T3? That's what we need to find. So 20 will go to the other side. T3 will come out to be 4 seconds. So initial time, listen to this, I'll tell you. I'll give you time to copy. Listen to this. See, T1 is 10 seconds. T2 is 25 seconds. T3 is 4 seconds. So what is going to be the total time? So total time will be equal to 39 seconds. That is first thing. What is the acceleration? Acceleration is, yes, it is 2 meter per second square. What about deceleration? It is 5 meter per second. So I'll call this as A1 and this as A3. This will be plus, this will be minus. So deceleration is minus 5 meter per second square. So these are all the values that they have asked in this question, right? I hope you could understand. All that we did is you just use the equations of motion depending on the data that you have it in your hand, right? So first copy this. I'll tell you a shorter way to solve this problem. So first copy this. This is very lengthy. Tell me. Time? 10, 25 plus 4. அந்த T2 மட்டும் தான் கால்குலேட் பண்ணேன். T2 is 25 plus 4 plus first 10. Done with the slide? Shall I proceed? Okay. So I'm going to rub this. I'm sorry, I pressed it by mistake. Control Z, sorry, mistake. I cannot get it back. Did anyone write? Can you share it? Did you write it? Akhil? You also didn't write. By mistake, I hit that key. I cannot do that operation back. Yeah, alternate way தான் erased it. You will copy. Sorry, space விட்டுரு. Or later you can copy it from someone else. So can I rub this also? Listen. This is, if I draw a graph between velocity and time, right? Because they started with rest. So an object starts from rest and it accelerates uniformly. So what is the graph for uniform acceleration? It is a straight line like this, right? It is accelerating uniformly at a rate of whatever we don't know, and it is accelerating till its velocity becomes 20 meter per second. So after that, it is moving, right? It is moving with a constant velocity, means it is going to be parallel to the x-axis. After that, what is happening? It is decelerating. Means it is coming to rest. Right? So are you able to visualize the three journeys? Right? Now, the question is, if I take this time to be T1, if I take this time to be T2, and if I take this time to be T3, right? So whenever you have velocity time graph, there are two things that you need to keep in your mind. One is slope. So slope of a velocity time graph is acceleration, right? What about the area under velocity time graph? It is displacement. So are these 2 points clear? So whenever you have velocity time graph, if you find the slope of it, you're going to get acceleration. If you find area, you'll get displacement. Suppose I take this area 1. What is going to be the area there? It is half into, so half into base into height, which is going to be 20, which is S1, right? So what will I get the value of? I'll not be able to solve this because there are two unknowns in the same equation, right? Now, what if I find the slope of it? So this point is T1 comma V, and what about this point? It is 0 comma 0. Accepted? Right. So when you apply the slope equation, what will you get? Y2 minus y1 divided by x2 minus x1. Right? So how much is that value going to be? Slope is acceleration. Right? What is the value of v that is attained there? V is 20. So 20 divided by how much time is it going to take? Oh, actually, sorry, they have given the value of T1. No, I forgot about it. It is 10 seconds. So here, if okay, I'll come to this one. So V is 20. 20 divided by time is 10 is equal to acceleration. Cancel it. A will be equal to 2 meter per second. Right. If you substitute it here, what is going to be the displacement here? It's going to be 100 meter. Right. So this is what we got in the first case. We got the displacement as 100 and the acceleration as 2 meter per second. So basically what you can do is, if you know how to draw this graph, all that you need to do is calculate area or slope. Is it clear? So you can copy it till here first. You can do that. Both are same. If you rearrange it, you will get V is equal to U plus 81. Copy it. No, draw the complete graph first. First draw the complete. That space will not be sufficient. Done. So we'll do for the third part of the journey. So if I calculate the area for the third part, what will I get? Half into 20 into T3. So half into 20 into T3. But what is this value supposed to be? Area is not retardation. The area is displacement. They told displacement is 40. So here put 40. So this will cancel this 2 times. T3 will be equal to 4 seconds. This is what we got. Right? We got T3 is equal to 4 seconds. So similarly, if I calculate the slope, so when I calculate slope, observe, this point is going to be some time. I don't know. The time is going to be T1 plus T2. I'm not concerned about time. It's going to be T1 plus T2. I'll write it as T. Okay. T1 plus T2 itself, so that you're not confused. And what is going to be the velocity? It is going to be 20. So how much is this value going to be? 0, 0 is here. It will be T1 plus T2 plus T3, comma 0. It will be T1 plus T2 plus T3, comma 0. Is that point clear? It will be T1 plus T2 plus T3, comma 0. So what is going to be the slope of this line? So remember the values. 20 minus 0, 20 minus 0 divided by T1 plus T2 minus T1 plus T2 plus T3. So T1 plus T2 minus T1 plus T2 plus T3 will give you minus T3. So it will give you minus T3. This should be equal to how much? So you already know that T3 is 4. Substitute it here. So A will be equal to minus 5 meter per second. This is A3. Am I clear with this? Right. And the last part is we need to calculate the area for the second part. Right. So we know that the first area is 100, second area is 40. Then how much will this area be? 500. So 500 is equal to what shape is it taking? Rectangle. So for area 2, I will write 500 into T2 is equal to, 20 into T2 is equal to 500. So T2 will be equal to 25 seconds. So basically area of rectangle 20 into T2 is equal to 500. So T2 will be 25 seconds. So 25 plus 4 plus the same 10 is going to give you, you'll get the same answer, right? So whichever is easy for you, you can take. If you directly want to go with the equations of motion, you can go with. So just do an analysis. Clear with this? Next slide. You're done copying this? You first copy it. Draw the diagram first. Do it. Let's proceed. Next slide. Huh? You're done. Done. So check the answer. No? How much? 39 seconds. Retardation is 5 and acceleration is 2. Correct. Right. So this is another set of problems that we need to see. But before that, we'll see another concept. Write it down. So motion of an object under gravity. So motion of an object under gravity, which we basically call it as free fall. Okay. See, if I have an object which is projected upwards with initial velocity u. Okay. So let's imagine the journey of this object. So how is it going to be? If you throw an object upwards, first what will happen? It will travel upwards, right? At some instant, it will come to rest. After that, its direction will change, right? So if I take this to be the instant at which it is coming to rest, okay? If I take this to be A and this to be B, then this distance is what is called as the maximum height. Okay, it is called as the maximum height, and the time taken by the particle is called as PA, which is called as the time of ascent. It's called as time of ascent. So the time taken by the particle to go from A to B is called as time of ascent. Similarly, the time taken by the particle to come back from B to A is called as time of descent. Okay, so time of descent, and the total time is called as the time of flight. So time of flight, so TF is given as PA plus TD. Are you able to understand this? Right? Now, one point that we need to have in our mind is, when this object is moving under the influence of gravity, it is experiencing a force always in the downward direction. So whether the object is moving in the upward direction or downward direction, it is always experiencing an acceleration in the downward direction, and it is experiencing a value of g. And what is the g called as? It is called as, it's called as acceleration due to gravity. So it's called acceleration due to gravity. Okay, it is not called gravitational constant. Gravitational constant is capital G. Okay, and the value of this is 9.8 meters per second square, or sometimes we can take it as 10 meter per second square also. So this value is taken closer to the surface of the earth. This value will change with respect to height, about which we'll see it in the gravitation chapter. As of now, understand that the object's motion is only in terms of few meters, where the accelerations can be considered to be 9.8 meters per second square, which is a constant. Are all these points clear? Right? Is this getting registered? Now, what we will do is, we will calculate each of these values by using the same three equations of motion. Right? So first, I will calculate the maximum height. So to calculate this maximum height, I need to know its story. So during the journey, when the object is trying to reach its maximum height, what is happening at the maximum height? The object is instantly coming to rest. So I told you, wherever the object is coming to the rest state at a particular instant, apply the formula v square minus u square is equal to 2as. So what is the velocity of the particle at point B? 0. So 0 square minus. What is the initial velocity? Let it be u only. So u square is equal to 2 into, this is where we need to be careful, right? So the question is, here we need to follow sign convention because we are dealing with vector quantities. Velocity, acceleration, and displacement, everything is a vector quantity except time, right? Now, which one should I take as positive and which one should I take as negative? For that, you're free to do. You're free to choose. Not necessarily that only upward direction should be positive. If you take one of the directions to be positive, the other obviously has to be negative. That is the only condition. Okay. So in this scenario, I'll go with the natural convention. That is, upward, I'll consider it to be positive, and downward, I'll consider it to be negative. So downward in the sense, any vector pointing in the downward direction, I'll consider it to be negative. It can be displacement, it can be velocity, it can be acceleration. Anything in the downward direction is considered to be negative, anything upward is positive. Having said that, v square minus u in this case should be taken as positive only, right? So I wrote it as plus u the whole square, it is u square only, is equal to 2 into, what about the acceleration? It is minus g. And what about the displacement? Displacement is maximum height, but the displacement was in upward direction. It was ascending. So it is going to be plus h max, right? I'll change this also as capital H. Okay, so that you'll understand both are same. Now, what is the value of h max here? It is going to be equal to u square divided by 2g. It is going to be u square divided by 2g. Right? This is the maximum height. Am I clear with this? So this is the first expression. So first make a note of this. Just consider this to be a problem and apply the equations of motion by yourself to calculate the time of ascent and time of descent. Just use the logic and calculate. Right. I'll give you 2 minutes. So what is the time of ascent you got? So for time of ascent, that is TA, what we'll get is we apply the formula V is equal to U plus AT. So time of ascent is taking place when the object moves from bottom to top. So what is the velocity at the top? 0. What is the velocity at the bottom? U. What is the acceleration at the acceleration during the upward journey? It is minus G into time. So which implies T is equal to U divided by G. And this is what is called as the time of ascent. So TA is going to be equal to U by G. Right. Then what is this time of descent? Listen, there is nothing like V here. Finally, it is not going to be at rest. Why will it be at rest? It is not going to come and touch. It is not going to come and touch the ground slowly. It's going and hitting the ground. So when it is hitting, it will hit with some velocity. Right? The velocity with which it is hitting is the same as the velocity with which you projected. It is based on energy conservation, but I'll not use that logic. Okay, I'll use another way to derive this. See, the object, when I calculate the time of descent, can I say that the displacement of the object is h max? So I'll use S is equal to ut plus half at square. Okay. What is the displacement of the particle? It is going to be h max is equal to, during the descending journey, what is the initial velocity? So final velocity of the upward journey becomes the initial velocity of the downward journey. So u is 0 plus half into, what is the acceleration? It is minus g only, but a point to be noted is h max, since we considered everything in the downward direction to be negative, you need to put a minus sign here also. See, when you're dealing something in the upward direction as positive and downward as negative, maintain the consistency throughout the problem. Don't change it according to the direction in which the object is moving. Maintain the consistency. So when it goes from B to A, it is minus h max is equal to 0 plus half into acceleration is downwards, which is minus g into time of descent square. Right? So minus, what is the value of h max that we derived? It is u square divided by 2g. So u square divided by 2g is equal to minus g divided by 2 into td square. Minus and minus are gone. 2 and 2 are gone. So time of descent will be equal to u square divided by, sorry. Time of descent square is equal to u square divided by g square, which implies time of descent will be equal to u by g. So one thing that you can observe here is, when there is no resistive force, here if you see, the object is completely moving only under the influence of gravity. The air resistance or drag, anything into consideration is not taken. When that is the scenario, then the time of ascent and the time of descent are exactly going to be the same. Right? So having said this, what is going to be the time of flight? It will be TA plus TD, which is going to be equal to 2U divided by G. Am I clear with this? Right? So these are all the expressions that are needed to solve the next set of problems. We saw an example, no? So we need those, we need these formulae to solve those problems. Okay? So make a note of this. Done? Everybody finished writing? Okay. So starting from here, want you all to do the problems on your own. Okay. So I have a small work. I'll just be back in less than 10 minutes. I'll be inside only. You keep doing. Next slide. Those who are online, solve this problem. Okay. So each problem take only 3 minutes.
Okay, sir.
இன்னும் எந்த ப்ராப்ளம் இல்லை, சிம்பிள் ப்ராப்ளம். Why? So there is there is a ball which is thrown vertically upwards with a speed of 19.6 meters per second from the top of a tower and returns to the earth in 6 seconds. Find the height of the tower. So how did you people approach first of all? So from the top of the tower only, is right. Yeah, throw it upwards. See, basically what should happen is, see, logically, let's say he's standing here in this square feet. Let's visualize, okay? If I stand in the middle, I hold it like this and throw it up, it will again come back to the top of the tower only. So for this to go and fall on to hit the ground, what should happen is he should keep his hand out of the tower and throw it upwards and remove his hand. Okay, that should have happened. Appada, it will go upwards. Let's say it is thrown with some velocity u, which is equal to 19.6 meter per second, right? Let the height of the tower be h. Okay. So it is traveling upward, reaching the maximum height, and from there again coming and hitting the ground. So total time it takes for this journey is going to be equal to 6 seconds. Right. So break the journey into two parts, A to B and from B to, let's say this point is C. Okay. So if I take the journey from A to B, what is the initial velocity? 19.6 meter per second. What is the final velocity? What is the acceleration? So G is downwards. So if you take upward as positive, downward is going to be negative. So it is going to be minus G, minus 9.8. Okay. And we don't know how much time it is going to take. So T, I don't know. Also, okay. So if I apply V is equal to U plus AT, right? V is going to be 0. So 0 is equal to U is 19.6 plus A is minus 9.8 into T. So let me call this journey as T1. I'll call it as V1 is equal to U1 plus A1 into T1, which implies T1 will be equal to 2 seconds. So time taken will be 2 seconds to go from A to B alone. So how much time will it take to travel from B to C? 4. Yeah, total time is 6 seconds. No, see, already 2 is lost in going from A to B. From B to C, it should take 4 more seconds, right? So in that 4 seconds, let's do an analysis. Here, how much is the displacement of the particle that we don't know, right? In this question, all that we need to find is the height of the tower. Okay. So if you ask me this problem, how you can solve is, if you throw with an initial velocity of 19.6, at this point during the downward journey, here also it will be 19.6 meter per second only, because there is no air resistance or something. This is the point I told you in the previous case, if you remember. But the only problem here is I don't know how much time it is taking for the particle to go from B to C. If I know that, I'll apply S is equal to UT plus half IT square, my job is done. Okay. Now from B to A, let me break the journey. So from B to A, what will happen is the final velocity in the upward journey will become the initial velocity in the downward journey. So the initial velocity in the downward journey is going to be, why? Because it has reached the maximum height. So there it is going to be 0. Right? Acceleration is minus. I told you, no, maintain consistency. Throughout the journey, upward is positive, downward is negative, minus. Make sense? Right. Now, if you are able to calculate how much distance the object has traveled in the upward direction, how much will be the distance? How much is the distance it has traveled? Even without that logic, you can tell one thing. since there is no air resistance, upward journey and the downward journey will take the same time because time of ascent and time of descent are the same. So it should take 2 seconds, but we'll prove it. Okay. So the only challenge is I don't know what is the velocity at that point, and I don't know how much time it is taking to travel from B to A. So for that, what I will do is, in the previous case itself, I'll calculate how much is the distance from here to here. So S is equal to ut plus half at square, which implies S is equal to U is how much? 19.6. 19.6 into time is 2. So it is 39.2. Correct. Minus half into 9.8 into 4. So this will cancel this 2 times. So 39.2 minus 19. So the distance traveled by the object in the upward direction is 19.6. So what will be the distance in the downward direction? S2 will be equal to minus 19.6 meter. Why? Downward journey. Okay. So if I apply S2 is equal to U2 into T plus half into A2 into T2 square, right? If I apply it like this, then minus 19.6 is equal to this value substitute. It will be 0. U2 is 0. A2 is also minus G. So plus half into minus 9.6 into, sorry, 9.8 into T square. Makes sense? 9.8 will cancel this 2 times. Minus and minus are gone. T square will be equal to 4, which implies T is equal to 2 seconds. This is what we know this already, because when there is no air resistance, the upward journey and downward journey will take the same amount of time. So this is the value of T2. Okay. Now, what are they asking us? Actually, what are the question's objective? We need the height of the tower. So to calculate the height of the tower, let me call it as H. So I'll apply the formula. S3 is equal to U3 into T3 plus half into A3 into T3 square. So you understood what is the third journey? What is the third journey? A to B is the first part, B to A is the second part, A to C will be the third part. So in the third part, S3 is what I need to find, so I'll call it as H. So wherever you have an unknown, never give a sign to it. You can ask me, since the object is traveling downwards, why didn't you put minus H? Because it's an unknown for me. Unknown, you should not give sign at all. H is equal to, U3 is how much? U3 is the initial velocity at this point. It will be 19.6. If you need, you can calculate and see, applying V is equal to U plus 8. You will get 19.6 only. So 19.6 into, what is the downward journey's time? 2. 2 while going up, 2 while coming down. So remaining time is only 2, no? So it is into 2 plus half into, what is the acceleration of the minus into T3 square is 4. So this will cancel this 2 times. So 19.6 into 2 minus 19.6 is 19.6 only. So this is the answer. I'm not sure how many of you got it. Then, yeah, you must know. So this is the answer. See, actually, I described the whole scenario. Okay, this is a textbook problem only. So when you solve this, you need to use 2 logics. You need not show all these things. You can directly come from this step itself. Suppose the same question is asked in MCQ, you cannot sit and waste this much time, right? So first thing that you need to know, whenever there is no air resistance in the question, right? When the object is traveling only under the influence of gravity, what are the important points to be kept in mind? First, time of ascent and time of descent are same. Secondly, whatever is the velocity with which you throw the object, it will come back to the point with the same velocity. This is happening because of conservation of energy. Okay. So when you take these 2 into consideration, directly go to this point and then solve. So why I told time of ascent and time of descent in this problem is going to help us? Because they gave us the total time, 6 seconds. So what is the time of ascent and time of descent put together? It will be 4 seconds. So for covering this traverse journey, it needs only 2 seconds. So you directly know that even without solving, right? And what is the value you need? Since they're asking about distance. So what are the two formulae that involve distances? One is v square minus u square is equal to 2as, or s is equal to ut plus half at square. Right? These are the two formulae that involve distances. But how will you know which formula you're supposed to use in this problem? You don't know what is the final velocity. That is one thing. And if you see, the question itself is dealing with time. So since time is involved, you will take this into consideration. So that's why I applied this formula. Did you understand? Right. So make a note of it. That is only for maximum height. You will get the same, but it's a reverse journey. Fortunately, what is happening is everything is dealt as a multiple of 9.8. Let me put in the problem 39.2, 19.6. Shall I proceed to the next slide? No. Rohit, let me know once you're done. Time 6. What is 6? Time up actually. 6:10. Okay, then we'll stop with this. Okay. So next week, the first 20 minutes, there will be a test on these derivations and two problems. Okay. So So
Sir.
whatever I told, type it.
Sir, could you repeat the test question?
No, this one. Well, motion of an object under the influence of gravity and two problems based on it.
Okay. Sir.
Okay. Yeah.
Thank you, sir.
Yeah.